Hello, am I audible?
Yes.
Oh, thank you.
Audible.
I request all the participants to mute themselves. Thank you. A very good morning to one and all present over here. On behalf of Electrical Engineering Department, Sarvajanik College of Engineering and Technology, Sarvajanik University, I, Krishna Trivedi, warmly welcome you, all the participants, to the wonderful journey of 1 week AICTE sponsored online FDP on Microgrid, a path to sustainability. I take privilege to welcome Honorable Principal Dr. Hiren Patel Sir, respected Head of the Department Dr. Shabbir Bohra, eminent speaker, faculties and dear participants. Prayer is an invocation to activate a rapport with an object of worship through deliberate communications. So let's have prayer first.
हसतो मा सर्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतङ्गमय ॐ शान्ति 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 हसतो मा सर्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतङ्गमय ॐ शान्ति शान्ति शान्ति
Thank you all. Now I would request Dr. Shabbir Bohra, Head of the Department and Coordinator of the FDP, to welcome the audience and brief about the FDP. So, over to you.
A very good morning. Today we are going to start AICTE ATAL sponsored FDP on microgrid, a path to sustainability. I'll just brief about the AICTE endeavor in this. So AICTE is in its endeavor to encourage academic excellence in technical education has taken several quality initiatives, which also include the enhanced impetus on the development of the faculty teaching in colleges across the country. The AICTE Training and Learning, that is ATAL Academy, is one such initiative that has been conducting various faculty development programs for imparting or upgrading faculty knowledge in different emerging thrust areas like Internet of Things, machine learning, artificial intelligence, robotics, renewable energy, augmented and virtual reality. Given the unprecedented COVID-19 backdrop, this year the 1500 FDPs in various emerging areas have been scheduled in online mode, and 25 such FDPs are commencing from today, that is 20th December 2021. These FDPs are being conducted by various prominent organizations across the country, engaging the distinguished experts from the academia, industry, research organizations from within the country and abroad. AICTE, there is a common inauguration function which will be scheduled at 11 a.m. So everybody is requested to join the common inauguration ceremony at 11 a.m. and the link has already been shared with you. Now, as far if we discuss something about the today's FDP, that is we are conducting at the Department of Electrical and Engineering, Sarvajanik College of Engineering and Technology. The purpose behind conducting this particular topic of the microgrid, a path to sustainability, is to create awareness among the faculty members, among the PG students, among the PhD scholars, and some of the personnel from professionals and personnel from the industry about the microgrid and what is its significance in today's time. So we'll be going through number of the discussions and sessions. There will be 14 such sessions as per the AICTE or the ATAL suggestions. So there are 14 such sessions that will be taking place throughout these 5 days, and the total number of the participants that we have in this particular FDP is more than 100 from the different states, from the different cities across the country. And I'll just give you some brief about the inaugural ceremony that will be scheduled at 11 a.m. So at 11 a.m. there will be a virtual arrival of the honorable chief guests and dignitaries. Then at 11 hour and 3 minutes there will be a virtual lamp lighting and Saraswati Vandana. At 11 hour and 4 minutes there will be a welcome address by Dr. Amit Datta, Deputy Director of ATAL Academy, AICTE. Then at 11 hour and 12 minutes, there will be an address of Dr. MP Punya, Vice Chairman, AICTE, followed by the address of Sandy Carter, who is a Vice President of Amazon Web Service, and the vote of thanks by Mr. Sundar Sen. And after that, we'll start the second session. So meanwhile, from 10 a.m. to around 11 a.m., we'll be having one session that is on the introduction of the microgrid and planning. So this is something about the FDP which we are going to conduct, and I again request all of you to join the common inaugural ceremony which is scheduled and arranged by the AICTE ATAL Academy. Okay, thank you very much.
Thank you, sir. Now I request Dr. Hardik Desai, sir, coordinator of the event, to propose vote of thanks. Dr. Hardik Desai.
Thank you, Krishna. Good morning to all of you. Dr. Hiren H. Patel, Principal SCET, Dr. Manu Bohra, Peer Reviewer of FDP from AICTE, Dr. Shabbir Bohra, Head of Electrical Engineering Department, faculty members, students and participants. It is a pleasurable moment for me to deliver the vote of thanks to all involved in the FDP, microgrid, a path to sustainability. I, on behalf of entire team of FDP and EED SCET, am grateful to the Sarvajanik Education Society and Sarvajanik University who are in favor of us for the arrangement of this type of technical activities. I also extend the heartfelt thanks to AICTE Training and Learning ATAL Academy for selecting the application of arranging FDP at SCET. It gives me immense pleasure to express my deep sense of gratitude to the principal, Faculty of Engineering, SCET, Dr. Hiren H. Patel, for his continuous guidance and wholehearted support. Moreover, I would like to thank all the resource persons from various IIT, NIT, universities, industries who are ready to express their key knowledge during the STTP. Also, heartfelt thanks to Dr. Manu Bohra, sir, for his presence. I'm also thankful to all the HODs present here for encouraging us. We are also thankful to all faculty members for encouraging us by their worthy presence. I also take this opportunity to thank all teaching staff members and non-teaching staff members for their help. We extend thanks to all the participants. And lastly, I also thank the Master of Ceremony, Professor Krishna K. Vakharia. Thank you.
Thank you, Dr. Shabbir, Dr. Hardik Desai, sir, to propose vote of thanks. Now, without wasting much time, we are directly start our session. So our first session is on introduction to microgrid and planning, and our eminent speaker is Dr. Shabbir Bohra, professor and head of the department, Sarvajanik College of Engineering and Technology, and coordinator of the FDP. He has more than 20 years of experience at SCET. He has published more than 20 papers at various journals and conferences at national and international level. He received grant under ITG scheme from AICTE. He awarded as guest researcher at Energy Technology, Aalborg University, Denmark. He is reviewer and organizing committee member for national and international journals and conferences. He is an Indian collaborator for Indo-Danish research program for PG and PhD scholars. Thank you. Over to you, sir. Entire screen share.
Hello. 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 So is the slide visible to you?
Yes, sir.
Okay. So I again welcome to the first session. That first session is on the microgrid introduction and planning. We'll be discussing something about the basics of the microgrid for those who have not yet jumped into this particular area, and then we'll gradually will switch over to the different planning strategies and planning of the microgrid. I'll just brief upon this FDP program, as I have already said before. So it is a 5-day program, and there will be 24 sessions. And we are very much thankful for that. Our Honorable Provost, Mr. Parsi Engineer, Principal, Dr. Hiren Patel, our other team members, Professor Naman and Krishna, and Dr. Hardik Desai. The outline of the presentation would be like this. We'll be discussing something about the ATAL FDP, the schedule and topics to be addressed during the FDP. What would be the significance and connection between the microgrid and Conference of Parties 26 that has held recently in Glasgow? Then we'll come to the different definitions and understanding of the microgrid, different salient features of the microgrid, existing microgrids globally and India, different classifications of the microgrid, examples of planning of microgrid, and the homework for analysis of the microgrid. So this would be the flow of the presentation. as we had already discussed this, so we'll be having the common inauguration at 11 a.m. to 11:30. And this is the entire schedule. So there are different speakers from different NITs, IITs, industries, and even there are 2 speakers. One is from the Recep Tayyip Erdogan University, Turkey, and one is from the Green Empowerment, Malaysia. And all these speakers are having enough expertise in their field of research. So let's come to the original business, that is the highlights of the 26 Glasgow. COP26 can be considered as one of the most anticipated and the biggest international summits so far in the history of the climate action. One of the key focus areas of the conference remains to devise a global net zero plan and keep the rising temperature check. As we know that the temperature is increasing day by day of the globe, and that may result to the melting of the ice. So that is a major concern, and the main cause of this is burning of the fossil fuel, GHG emission, etc. UK Prime Minister Mr. Boris Johnson has established an international program to bring clean and affordable technology everywhere by the year 2030 to achieve the goal of net zero. And that agenda has been signed by most of the countries like US, India, European Union, China, and other developing countries. 23 countries, including the world's top 20 coal-fired power generating countries, have made pledges to phase out the coal power. So in a way that we could substantially reduce the emission, decarbonization, and that may lead to that may somehow prevent the rise of the temperature. India currently ranks the 4th worldwide in installed renewable energy capacity, and there are mainly 5 points that resolution has contained, which is bring its non-fossil based energy capacity to 500 gigawatt by 2030. By 2030, fulfills 50% of its energy requirement through the renewable energy, cutting down its net projected carbon emission by 1 billion tons till 2030, and reduce carbon intensity of its economy by more than 45% by 2030. And by 2060, India wants to become a net zero. So these are the 5 main targets or the points discussed during the COP26, and that was discussed by our honorable Prime Minister Mr. Narendra Modi. So that I'm just trying to create the link between the microgrid and microgrid, a title which is a microgrid, a path to sustainability, why it is a path towards the sustainability. So as we proceed, as we go ahead, you will come to know that what would be the connection that has been established between this microgrid and the sustainability. In 2004, the microgrid was defined as there are different definitions given by different researchers, different organizations. One of them is a better way to realize the emerging potential of distributed generation in a systematic approach, which views generation and associated loads as a subsystem. So there are a number of generators, distributed generators, there are a number of loads. The system is like a small bunch of loads and sources. Microgrid concept was firstly introduced by USS Consortium for Electric Reliability Technology Solutions. That is to reduce the cost and increase the reliability, increase the quality of the power across the world. The DOE, that is the Department of Energy Microgrid Exchange Program, MEG defines it as the microgrid is a group of interconnected loads and distributed energy sources within clearly defined electrical boundaries that act as a single controllable entity with respect to the grid. So basically it will be treated as a single entity, and there are a number of interconnected loads, number of energy sources, it may contain the conventional sources and non-conventional sources, or the non-renewable and the renewable sources as well. A microgrid can connect and disconnect from the grid to enable both grid connected and islanded modes of the operation. Then if we consider the different features from this definition, then in general it can be described as the microgrids are electricity distribution system which contains loads and sources such as distributed generators, storage devices, controllable loads, and can be operated in controlled, coordinated manner. It is a flexible and dispatchable system. It is capable of operating in either modes. It can be grid connected, it can be standalone. So whenever we are talking about the grid assisting technology, then we need to go for the grid connected system. And if we are designing, if we are planning for such system in order to have the access, in order to increase the access to the electricity, then we should think of a remote system or the remote location. So in that case, it may not be connected with the grid because of non-availability of the transmission line. So that is a standalone or the remote system. It can potentially reduce the dependency of its consumers. Sorry for interruption. It can be grid connected or standalone system. It can potentially reduce the dependency of its consumers on the traditional generation system by providing the different types of the energy. It could be electrical energy, it could be thermal energy, it could provide the ancillary service trading activity between the microgrid and the main grid or the macrogrid. If we look at the grid structure, then there are three types of grids that we may come across. One is a utility grid, which is also known as a macrogrid. Then comes mini grid and microgrid. It is very difficult to distinguish between the mini grid and microgrid, so that can be used interchangeably. And then comes a nanogrid. So as the name itself suggests, that they are defined based on their power handling capacity. So microgrid configuration can be AC if it is the generation is AC, loads are AC. It can be DC if the generation is DC, loads are DC, or it could even be hybrid. So in that hybrid configuration, you may be having AC-DC generation and AC-DC kinds of the loads. One of the significant reasons why the developing countries adopt the microgrid solution is to solve the problem for the rural electrification. As I have just rightly mentioned that when do we need to go for the standalone system? So there are so many places, even in India and outside of the India, like in Africa also, where it is very difficult to install, it is very difficult to stretch the transmission line. The cost of the extension of the transmission line itself is very high. So and there are some pockets, there are some households where the people are living without electricity. So how this problem can be solved? So one of the solutions, this is not the only solution, one of the effective solutions is to develop a microgrid where there is a load and when there is a scope of a source. So that obviously the loads are there, but there should be some scope of the arranging or controlling the energy source. So it's a localized group of interconnected load distributed energy sources connected with the main grid, and generally it operates in synchronism with them. The grid connected microgrids are comprising multiple generators, distribution systems, and sophisticated controls. They offer numbers of such benefits such as grid resiliency, improved power quality, low impact on environment, thereby leading to the increased demand. So it makes the grid more resilient. It assists in improving the quality of the power. And apart from that, there will be a lower impact on the environment. So the growth of this segment can be attributed to the expansion of the utility-based network, grid networks globally, which is coupled with the large-scale harnessing of the renewable sources of the energy, and it may be onshore wind or offshore wind mechanism. These grids can also work off-grid in disconnected mode. Any small-scale localized station with its own power generation resources and loads, as well as the definable power supplying boundaries, qualifies as a microgrid. It can be used as a backup or the supplementary power source for main grids to cater the increased electricity requirements for the end user. So based on the discussion up till now, now we can say that the microgrids are nothing but the smaller version of the macrogrid, where the macrogrid or the utility grid has hundreds or thousands of generators connected together and millions or billions of loads connected together. So if we try to shrink that this mechanism to a smaller power handling, then it would be known as the mini grid or the microgrid. Generally, the mini grid term is not very popular, and instead the microgrid term is very popular. So as I already mentioned, it is very difficult to distinguish between mini and the microgrid. So generally, more focuses on the microgrid development, planning, controlling, and its optimal energy or the power management, etc. Global warming and growing energy demand are the most significant drivers for spurring the renewable energy sources in order to reduce the greenhouse gas emission that is caused by the fossil fuel based electricity generation. Distributed energy sources are solar photovoltaics, wind turbines, combined heat and power units, and controllable loads such as electric vehicles are expected to play a considerable role in the future electricity supply. Globally, an approximate 6,900 terawatt hour of the electricity was generated from the renewable sources in 2019. That is a significant increase of the 5.5% when compared to the renewable electricity generation in 2018. And that this data was published in a recent COP26 summit. Now, what are the benefits, main benefits? If we're trying to list out the benefits of the microgrid, why we should opt for the microgrid, why should it be encouraged? So just in order to brief them out, what are the benefits? One of the benefits is the carbon emission reduction. Second is the energy efficiency enhancement, power quality and reliability improvement. It helps in line loss reduction with the local power delivery. So it is very clear that the transmission lines are of hundreds or thousands of kilometers long, and that causes the line losses. So why not to go for the local generation and local power consumption? If we go for the local generation and local power consumption, then the line losses can be avoided, or it can be reduced to a very great extent. Increasing power transmission capability in DC microgrids, deferral of grid expansion plans, and much smaller financial commitment. So if the grid expansion can be delayed, if the grid expansion can be deferred, then with that also it helps in the smaller financial burden to be taken by the state or the central government. Besides requiring the fewer technical skill for the operation, relying more on the remote control and automation. So that requires a less skilled manpower, though sometimes it may be true, sometimes it may not be true. So there are two sides of this particular benefit. But right now we'll not be going into the much detail of that. There are numerous advantages that we have seen, that it has almost 6-7 very fascinating advantages or the benefits. But apart from that, if you look at the darker sides of this system, so what are the challenges? There are different challenges in different areas, like technical challenges, regulation challenges, economical challenges, and marketing challenges. So in order to just discuss the technical challenges, renewable energy sources are intermittent in nature, means they are dependent on the weather condition. they are not consistent enough in order to meet the demand. So it may be possible there are more generation when there will be a less demand, or vice versa is also possible, then there will be a less generation when the demand is more. So because of the, apart from that, their capacity is also small. They are sensitive to the unpredictable changes and causes problems with the operational capability. The uncertainty of the islanded microgrids is much greater than that of the utility grid. So frequently the microgrid gets disconnected from the utility grid. So that is the islanded operation. Islanded operation can be intended, can be unintended, can be planned or unplanned. Then the low inertia system can lead to the intense frequency deviation due to the numerous power electronic based units and lack of the conventional synchronous generators. Now the conventional system or the microgrid, that is consisting of the synchronous generators, and the synchronous generators are having very large inertia. And if you come to the non-conventional kind of the generation, non-conventional kind of the electricity generation, they are basically employing the power electronic devices. And if you look at the power electronic devices, inverters, converters, then they are having the very low inertia. So there is a very significant impact of this inertia. We are talking about the electrical inertia when there will be a fault in the system. So that inertia also plays a very vital role in the reliability of the system, entire system. One of the major challenges faced by the microgrid in islanded mode is maintaining the balance between the generation and the load continuously. That we have just discussed, that it may be possible that sometimes then there is a load, that won't be generation, and on the other end there won't be generation when there will be a demand, higher demand. Second is the regulation. The current regulatory framework was not designed to incorporate number and types of different distributed energy sources or the microgrids. So still many countries are working on the designing the regulatory framework and the standards and codes for microgrids. Some of the common grid services provided by the energy storage devices are categorized as power quality, transit stability, regulation services, spinning reserve, voltage control, arbitrage, load balancing, congestion, firm capacity, etc. Now, the very interesting aspect of that is the economical. Despite the advantages in technology, the investment cost remains in microgrids. The cost of the energy storage system, some of the distributed generation such as the photovoltaic and fuel cell is still high, and it may not be affordable. Apart from that, that requires very efficient energy management system. Because of the smaller system, small amount of the power is being handled, and that's why the efficient and the effective energy management has to be addressed. Marketing, as microgrids can participate in market by selling their products and services, may be grid connected, may not be grid connected. It also plays an important role in developing free local markets by encouraging energy users to install the distributed energy sources, offering new services and supporting self-consumption. Denial of local energy trading among the DG and demand, and microgrid market positioning difficulties. So these are some market restrictions also, because it may be dealing with the main grid, utility grid, it may be assisting the main grid, it may be providing support to the main grid under the abnormal condition. So in a way that it has to deal with the main grid. The transaction of the energy, transaction of the power needs to be well defined, and based on that the selling and buying should be controlled. It is a cost-effective solution. Developing countries have taken more economical steps in adopting the microgrids to provide the electricity to the remote centers or the remote areas. Mainly the microgrids, most of the microgrid solutions are renewable energy based. So instead of installing the thermal or coal power plant as a part of the microgrid components, we prefer to go for the solar photovoltaic, we prefer to go for the wind, we prefer to go for the biogas biogas based generation. We prefer to go for the small hydro based generation, and so on. Another factor that makes the microgrid solution appealing to the developing countries, in a bid to comply with the Paris Agreement and other sustainable climate treaties, microgrid programs are primary channel through which these countries promote the clean energy policy. It provides reliable electricity. A common characteristic of the central grid in developing countries is unstable supply. And this is due to the several factors like shortage of the fuel sources, especially for the non-renewable kind of the sources, inefficient or less reliable grid system, over demand of the energy, and even sometimes the political factors may influence. Statistics by the International Energy Agency predicts that there will be a tremendous increase in the development of the microgrids. By 2040, about 80 million people will have access to the electricity through the microgrids. Now, still at the recent published data, almost 10 to 11% of the total population are depriving of the access to the electricity. Okay, and the rate at which the electricity is made accessible to them is around 1.5% per year. So if we look at the typical structure of the microgrid, then this microgrid is consisting of a load. It is a communities and institutions, a load, commercial and industrial building, households, controllable loads, combined heat and power, generator, energy storage. Energy storage could be a battery, it could be flywheel, it could be pump storage, it could be anything. Renewable energy means it may employ the wind turbines, solar photovoltaic, may be grid connected, may not be grid connected. The same is being projected over here with some more components to be added. So that indicates that there will be a bulk power generation, particularly it is a grid interactive or the grid connected system. Then it is connected with the transmission line, and the bulk power transmission is taking place at 138 kV, 220 kV or 500 kV. Then there will be an industrial customer. Now, if you look at this part, then there is a renewable energy integration. The energy storage is also part of it. So you can consider this as this particular part as the microgrid. As particular part as a microgrid, which is connected through the DC to AC inverter, and it is interacting with the main utility grid. Similarly, over here, this can be another microgrid. Similarly, this can be another microgrid. So here also all this generation is at DC level, DC, and then that is converted into AC to a suitable voltage level, and that then it is integrated with the existing grid. When we talk about the DC microgrid, then there will be either DC generation and DC transmission, and the loads are almost all loads are DC, or if there are AC loads, then that DC needs to be converted into the AC required level of the AC. So here, as you can see over here, there is a 230 volt AC generation, then there is a AC to DC conversion, and the bus is the DC bus. There are DC sources, the solar photovoltaic and wind turbine. The wind turbine is basically generates AC, and that is converted into the DC. So it is connected with the DC bus. Then there are batteries, capacitors, super capacitors, maybe electric vehicle, and there are output. On the output side, you have AC and DC load. So it is a combination of AC and DC load. For handling, for catering AC load, that requires DC to AC conversion. In order to cater the DC load, either the voltage level needs to be changed. So it could be a DC to DC converter. It may be DC to DC converter required, may not be required for this case and this case. So this is an example of the DC microgrid and the schematic of the microgrid, DC microgrid, how it would look like. If we look at the AC microgrid, then AC microgrid is consisting of the solar photovoltaic, DC to AC converters, AC to AC converters in order to make the system more compatible to integrate with the main grid, battery energy storage system. There are AC as well as and DC loads as well. Then AC-DC microgrid or the hybrid microgrid, which has AC part of that is AC microgrid, part of that is a DC microgrid, and there is an AC bus, DC bus. They are also coupled with some kind of the semiconducting arrangement. So the utility grid is also connected with the AC. AC loads are also connected with the AC bus. There are certain DC loads. These loads are connected with the DC bus through without any bridging device like DC to DC bidirectional converter or without any converter mechanism. So talking about the microgrid projects, according to the report given by the Navigant Research, by the second quarter of 2019, there were already 4,475 microgrid projects all over the world. And these microgrids sum up to the whopping 27 gigawatt of the total installed capacity. So which is not a smaller one. The 27 gigawatt of the capacity that is shared by the microgrid projects all over the world is a good number. The global microgrid market is estimated to grow from $24.6 million to around $42.3 million by 2060, and at a rate of 11.4% for 2021 to 26. The growth of the microgrid market is driven by many factors such as rising focus on decarbonization, increasing demand for the uninterrupted power supply, rural electrification, cyber attacks, etc. Initiatives by the government of different countries to encourage the development of the microgrids are also encouraging the growth of the market. I mean the microgrid market. This is just an example which is being taken. So it is a Gasa Island microgrid in southern Korea. This is just to add the flavor what it contains. It is that is a battery system, 3.2 megawatt hour. Then wind power contribution is around 400 kilowatt. Solar photovoltaic contribution is around 320 kilowatt. Diesel power is 300. So it is a combination of renewable and non-renewable along with the storage system. Average load of this particular sector is 95 kilowatt, and the peak load it may experience is 173 kilowatt. It was commissioned in 2014 and for the renewable enhancement application, and it caters around 300 people or 170 households. There are different case studies. You can find the links on the respective slides whereby you can get more details on it. So there are 3 case studies, 3 notable microgrid programs among the developing countries. One is from the Indonesia, second is from the Africa, and third is for India. So Indonesia is a country with around 34 provinces, and there are around 70,000 islands, and half of the population living in the rural region. Now before that, only around 66% were having the access to electricity, and over that 88% of the Indonesia is now being electrified. Now that is because of the project known as the Bright Indonesia. The the goal of the Bright Indonesia is to provide around 1 gigawatt of the electricity to over 12,000 villages where the electrification is needed by 2019. So this is just in process. Second is a Power Africa, that is Power Africa Beyond the Grid. In this particular example, Beyond the Grid is an initiative of the United States government to make the 30,000 megawatt of the new and clean energy available to over 60 million African households in remote and rural region by 2030. And according to the latest report, the program has brought around 56 power projects, which are already generating 3,481 megawatt of the power connected to the 14.8 million homes and businesses. especially in SSA, that is a sub-Saharan Africa. Third is the Smart Power India, in which the renewable microgrid solutions to at least 25 million Indians spread across the different 6 states. And in the latest report, Smart Power India had over 160 microgrid solutions spread in 4 Indian states, that is Bihar, Uttar Pradesh, Odisha, and Rajasthan. And the microgrids were over 80% solar powered, and their power capacity ranges from tens of kilowatts to around 70 kilowatts, and more than 70,000 people in remote areas of the India now have access to the sustainable electricity. Besides this, India's largest integrated power company, Tata Power, has planned to set up the 10,000 renewable microgrids by 2026, which is almost twice than the number of the microgrid projects identified by the world today. As we have seen that the number of the projects were around 4,500 or around 5,000. So we are planning to have almost 10,000 in India only. The Tata Power formed the new company TP Renewable Microgrid to build, own and operate microgrids. And this microgrid will add to around 10,760 megawatts of the conventional and renewable generation. Now, up till now, what we have just discussed, what is a microgrid, trying to connect the sustainability feature and the microgrid, how the title of this particular FDP is being selected, what is the connection between the microgrid and the sustainability. So just up till now, what we have discussed that. Now let's go into the much detail of the microgrid. So first and foremost, it comes that the classification of the microgrids. What are the different types of the microgrids? So it can be categorized in a different manner. One is by type. So it could be a campus microgrid, it could be a military microgrid, it could be for the residential microgrid, it could be a commercial or industrial one. So for example, one may go for the institutional microgrid. So they are maybe having the solar photovoltaic arrangement, they may be having their own diesel generator, maybe having their own biogas plant. So they can go for this kind of the microgrid. It could be institutional, it could even be campus. Similarly, it could be for the commercial and industrial. Second is by size, small and simple, handling capacity of around hundreds of kilowatts at low and medium voltages and supplying just a few customers, a few hundreds, few tens or hundreds of the customers. And on the contrary, large and complex ones, which microgrids are handling or catering thousands of either households or the commercial, or even it may be for a small pocket for the residential sector. Third is by the application to provide premium power to the resilience oriented services. So if an industry or a segment or a setup feels that the power which is received from the utility grid is not up to the mark, or the power quality, they have to compromise with the quality of the power, then they may go for their own microgrid establishment. The ability to withstand and recover from the high impact, low frequency events such as deliberate attacks, cyber attacks, or naturally occurring incidents. So that is also, there may be a number of interruptions, there may be a number of blackouts. Now, in order to handle those abnormalities, even the industry may go for the different or the required size of the microgrid. Then comes by mode of the operation. It could be grid connected, as we have already discussed, is exchanges power with the upstream grid depending on the electricity generated and the load demand. If there is a surplus demand, then the microgrid is pumping power into the grid. If there will be a more demand in that particular microgrid setup, then it may draw the power from the main grid or the utility grid. Second is islanded due to the faults in the plant and in maintenance. So it could be planned islanding, it could be unplanned islanding. It may face the challenges in regulating the voltage and frequency or maintain the required quality of the power during the islanded operation. By configuration, loads, micro sources, storage devices are integrated and lead to the different configurations. So that is AC network microgrids, especially it could be in the area of the distribution of the AC. There are three types of it: single phase, three phase with neutral, and three phase without neutral. Second comes the DC network microgrid for the emerging DC sources and loads. It could be monopolar, it could be bipolar, it could be homopolar, or it could be a hybrid, which is a blend of AC and DC microgrids. Then comes by the feeder configuration. Urban feeders are loaded in congested industrial area with low imbalance degree because of the short distance, low voltage drop, and it would lead to the low voltage drop. Second comes by the rural, so that these feeders are placed in rather more populated area compared to the urban, and the distance between the main body and the lateral is fairly long again compared to the urban, and because of the scattered load, non-flat voltage profile would be experienced. In urban, there would be a more low voltage drop, and in the rural cases, there will be a non-flat voltage profile experienced by the consumers. And then the off-grid in islanded mode, remote area, large size, distributed energy integration, etc. So these are the different categories. And when we want to plan a microgrid, we have to consider the requirement of that particular microgrid. What this microgrid is designed for, what is the primary application, what is the main application, what is the main objective of installing, designing the microgrid is very important. So if you look at the different planning stages of the microgrid, so it is a very common structure for any of the decision making. That first one has to define the problem, then one has to identify the requisites, identify the objectives, explore the feasible alternatives, enlisting the assessment criteria, selecting an application of the design making tool, and then after the last comes the verification and a validation of the particular project. So if we look at this, then what are the steps to be considered? Identify the problem nature, prepare the hierarchical structure for the problem for evaluation, select appropriate MADM method. Now this particularly on the right hand side, we are talking about particularly for the multi-criteria decision making methods for the evaluation of the project. So you will be having a number of options, and each option is having number of attributes, and you are asked to select the best one. Or you have to prioritize those alternatives. So you may be having a solar photovoltaic, you may be having wind, you may be having hydro, you may be having fuel cell, you may be having battery, and so these are the 4 or 5 options that you have, and all these 4 or 5 options are having their different attributes, their different features. Like solar photo, if you go for the solar photovoltaic, then what is the cost per watt, what it would be, it's a capacity factor, utilization factor, its life cycle, what would be its impact on the environment. So there are certain attributes which are associated with that particular option or particular alternative. Now you may be asked to prioritize the alternative, say the solar is the best, then comes wind, then comes bio, then that comes the hydro, or it may be a combination of the sources. So that in that way, the holistic kind of the analysis is to be done. So this particular this is one of the methods using which you can select or prioritize, or ranking can be decided for the different alternatives available. Select the appropriate multi-attribute decision making method for the evaluation. Collect relative weights scores each criterion for each alternative. So then after each criterion will be assigned some weight, and based on that each alternative will be assigned some weight. Then determine the best alternative based on the aggregated values of the relative weights corresponding to the chosen alternatives. So this is the way the microgrid can also be planned. So what is the planning for the rural microgrid? Say for example, if we want to go for the rural microgrid, then the recommendations from the various literature are categorized into this three broad ways. One is the strategic planning, then comes operation, and then comes social context. So in strategic planning, the groups of the set of the practices that reduce the sustained uncertainty and risk for the developer, including the market and supply chain assessment, technological choices, and the government policy existing in that particular region or the area. Second comes the operation. It has clustered technical, commercial, financial aspects which pertain to the microgrid enterprise. And the third, but not very least importance, is the social context, which gathers the activities relating to the community involvement and the services. So that includes the inclination of the stakeholders, various stakeholders. The stakeholder could be the manufacturer, it could be a consumer, it could be a utility. Now, if we look at the optimal planning, this is planning for the rural microgrid. What would be the optimal planning for the microgrid? The two principal economic elements are to be considered. One is the total net present cost, that is the NPC, and the levelized cost of the energy, that is the LCOE, that depends on the total annualized cost of the system. Basically, if we look at the only the financial aspect of the planning of the microgrid, then we need to consider these two important or the sensitive tools, that is the NPC and COA. Because of that, the user needs to calculate the annualized cost of the system, which is the components annualized cost subtracted minus any miscellaneous cost. So if we look at the financial or the economic aspects only, then these are the some segments. One is the electrical load. That is, for example, I'm taking a hypothetical rural community which is having around 5,000 units per day and having something around 1183 kilowatt of the peak demand. Then let's say, for example, the thermal load is also there. So the 5% approximated is the 5% of the electrical load, and it is having a scale annual average of the 500 units per day, while the scale peak load is around 51 kilowatt, and it is having a load factor of around 0.36 or so. Then what is the solar resource? Annual average radiation I need to take into account. Say for given region, it is 3.64. These are some of the numbers just to give you some idea that what we should consider when we are going for optimal planning of the microgrid. So it is 3.67 units per meter square per day. If it incorporates the wind resource, then it is an annual average wind for this area is this particular area is 5.78 meter per second. And then if it involves the conventional kind of the source, that is a diesel generator base, in order to meet the peak demand, in order to meet the emergency demands, then the diesel prices, say for example, now prevailing today is around 89 rupees as far as particularly where we are living in Surat, Gujarat. So it is around 89 rupees per liter with an emission density of 820 kg per meter, and it contains the carbon of around 88% and the sulfur content of around 0.33%. Then comes to the system economics. The annual real interest rate considered is 0.6%. For example, the real interest rate is equal to the nominal interest rate minus the inflation rate, and the project lifetime is around say 20-25 years. So these are the some of the factors that we need to consider when we are going for the optimal planning of the microgrid. I've taken just one of the literatures available for just sake of understanding. So here the authors have used the Homer, which is a simulation tool developed by the US National Renewable Energy Laboratory, and it is to assist the planning and design of the renewable energy based microgrids. The physical behavior of the energy supply system and its life cost, which is the sum of the capital and operating cost over its lifespan, is being modeled using the Homer. So as you can see, the different input data on option sizing and other parameters. So they have taken wind as for the life of 15 years, and the other information, so the Weibull distribution they have considered. The solar as say expected life is 20 years, D rating is 90%. Micro hydro they have used, and around 500 liters per second of the flow rate. The life is around 25 years. Similarly, they have also used the batteries, The battery capacity is around 845 kWh, nominal capacity is around 225 ampere hour. Converter grid extension is not there. Diesel generator 0 to 1500 kilowatt, 5000 hours, and the minimum load ratio is 30%. Okay, so at least it should be operated at the 30% of the load. Minimum load ratio is the 30%. Then and only it would be efficient. And the grid extension part, there is no life. It has been presumed that it lasts forever. The price of the electricity that they have considered as a $0.14 per unit, etc. And this would be the kind of the structure that they have analyzed and studied. Similarly, as we had recently discussed, the planning of the microgrid using the particularly multi-criteria decision-making technique. So in that, most of the critically influencing criteria. Now, which criteria we should consider? So I'm just trying to highlight those things such as economical, technical, structural, operational and maintenance, environmental and social aspects are being focused on. So these are the main, the wings or the facets of the planning when we are going for the microgrid. Not only the economic criteria are important, there are other criteria, they are also equally important, like the technical, structural, operational and maintenance. Apart from that, environmental and the social also. So a model for planning of energy sources for the microgrid using the multi-criteria decision-making technique based on the analytic hierarchy process, which is abbreviated as HP approach. The main utility grid acts as a primary source of electricity, and the conventional sources like diesel generator are also part of it. Gas-based combined heat and power is also part of it, and with the absorption chiller to meet the cooling demand of the facility. So this could be for a place where there is a cooling demand. Proven and comparatively most environmental friendly renewable energy sources are being employed, such as solar photovoltaic with the battery energy storage system. So what would be the stages through which the planning can be done? So one is the objective is the forming of the microgrid. Now, one, we have to identify the different alternatives, the fusion of the two or more energy sources or the blend of the two more energy sources. It doesn't mean that only, as I have already mentioned before, that not only the individual sources are to be prioritized or the rank, but instead it could be a group of multiple energy sources. Then what are the criteria to be considered? Economic, technical, structural, operational and others. Then compute the weight of that. Now there are different methods of computing the weights. Again, I will not be going into the detail of how the weights are to be computed, but let me tell you in a very brief way that the weights can be computed subjectively or quantitatively, or qualitatively as well as quantitatively. So you may ask the views or the views of the experts and assign the weight, or if the quantitative details are available, then you can directly fetch those details and you can incorporate those details in finding or in assigning the weights to the main criteria and the sub criteria. These we are calling it as a main criteria, that is the economic, technical, structural and operation. This we are calling it as a main or the primary criteria. Okay, and the other associated attributes we call it as sub criteria. Say for example, sub criteria for economic, sub criteria for technical, that will in the upcoming slides. Then there will be a multi-criteria decision-making processes to be executed, and that gives alternatives ranking, and then we need to verify whether the objective is achieved or not, and from that the best alternative is to be selected. Okay, so as I discussed in previous slide, that what are the different aspects, what are the different secondary criteria to be considered. Say for example, if we look at the economic issues, then the economic issues, there are mainly four or five vital tools which decide the economic influence. One is the initial cost of the investment, energy cost, operational and maintenance cost, and internal rate of the return. So the descriptions are given in front of that. So initial cost is that includes the cost of the equipment, transportation, labor, etc., except land cost. So we have not included the land cost. Similarly, the estimated internal rate of the return, it is the discount rate which makes the net present value of all the cash flow from the particular project equal to 0. Then if we look at the structural issues, then that includes the footprint, the size required for that particular resource or the source to be erected or installed, then the lifetime of it, modularity, whether it is a modular in nature or not, installation lead time in terms of the months, it may take 3 months, it may take even 24 months, annual performance degradation, which is very important. It should not be like that. Today it is offering 99% efficiency, and after 5 years it would be offering 99% of the efficiency. It would be operating at the 99% of the efficiency. Then definitely there will be some degradation. So it is categorized under the annual performance degradation. Then comes the technical issues. The technical is in-house or the local technical skill requirement, whether it is available in that particular region, what is the level of skillness required. Then self-sustainability or the islanding feature, if it is getting disconnected, whether it will self-sustain or it may not self-sustain. Availability of the fuel, if it includes the fossil fuel, then in case of an emergency, in case when the natural resources, or that when there would be no sufficient wind, there will be a cloudy season, there won't be availability of the sufficient irradiation, then what would be the cost of that? That also matters much. Then the generation capacity of each and every component. So it should not be like that the one is able to generate 1 kilowatt of power and the rest are of the order of 50 kilowatts. So that is a quite mismatch kind of the combination. Then the operational issues, the efficiency, which is very crucial in that case. The operational days per year, how many days that particular source remains operational. It would be offering, say for example, the source would be offering very good efficiencies in 90%, but it can only be operated for a few days, 10 or 15 days per year, then it is of not useful. So estimated energy production, that is again the same thing. The force outage rate, reliability, capacity utilization factor, which are also very important. And the others, that other includes the environmental aspects, social aspects, stakeholders' preference and inclination. And that includes this particular criteria includes the noise level, CO2 emission of the pollution, aesthetics or the elevation, and the stakeholder inclination. So the details are given. I'm not going to detail of that. Apart from that, the inherent nature has been mentioned. So inherent nature, what is the inherent nature? Say for example, if we look at the economic issues, and economic issues in first part, the initial cost of the investment. So that initial, what should be the initial cost of the investment? So that inherent nature is, it should be as low as possible. In contrast to that, estimated internal rate of the return, if you are talking about, that it should be as high as possible. So that is the meaning of the inherent nature of that particular criteria or the sub criteria. So that there are different criteria we have considered, or more than 20 criteria have been considered, and they are having their own inherent natures. So it is not every time that footprint should be low and lifetime should also be low. If the footprint requirement is very low and the lifetime of that particular resource should be as high as possible. So based on that, an analysis has been carried out, and that indicates that the economic, operational, structural and technical and other, so the weights are assigned over here, the computed weights are given as over here. Similarly, it is for economic criteria, only for economic criteria. This is for the selection criteria of the economic, operational, structural, technical and other. Then it comes to the economic criteria, wherein the initial cost, energy cost, internal rate of return and maintenance cost weightages are calculated. Similarly, for the structure criteria, technical criteria, operational criteria and other criteria. And in that case, one can observe that the pollution or the CO2 emission is given the highest weightage. Similarly, over here, if you look at the operational criteria, the highest efficiency is to be expected. along with the energy production. Looking at the technical criteria, the generation capacity should be very high. If you look at the lifetime, then the structural in a structural criteria, the lifetime years and is followed by the annual performance or the performance degradation. Similarly, the economic criteria, the initial cost, energy cost, internal rate of return, and maintenance cost are in decreasing order. So that depends upon the objective of the decision maker or the planner, that which criteria is given the highest priority. Whether the objective is to make the system environmental friendly, then we have to focus on the pollution, CO2 emission, etc. Whether we want to establish, whether we want to go for the plan a microgrid with minimum initial cost or minimum energy cost. So there are the different aspects and objectives. One should be very clear while planning for the microgrid. So it is almost we are approaching to 11 a.m. So I'd like to stop over here. I'd like to stop over here at this point of time, because we need to join to the central common ceremony for the AICTE. And if you have any query, any questions regarding this session, then definitely I would rather be happy to address. So all participants are required to join the common inaugural ceremony. The link is already been shared with you, and if you do not have that link, I will just so this is the link, and I'll also switch over to that particular inaugural ceremony part.
Sir, I have already shared the link
Okay.
in this chat box.
Okay, fine. So even in here also, I'm connecting to that link on itself.
Dear participant, we are sharing our screen over here, YouTube screen, so that you can attain this inaugural ceremony over here only. Right?
Okay, ma'am. No need to join over there?
No. I'll share
Okay,
my screen so that you can attend from here only.
Okay, thank you, ma'am.
Welcome. And our next session will be at sharp 11:45 of Dr. Vivek Agarwal from IIT Bombay. So you all are requested to join that session at sharp 11:45. Thank you. Okay, is it visible to everyone, the screen?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, thank you. So within a few minutes, they will start the ceremony.
Question